Hey guys, it's Ms. Felchner. We're going to solve absolute value equations on page 58, 2-6. Our objectives here, super simple. We're just going to write and solve absolute value equations. To solve an absolute value equation, apply the definition of absolute value to establish two cases. So we're going to solve each case after that. So remember, absolute value is the distance from zero. It is always positive. Anything inside of the absolute value bars will always be positive. Okay, so let's check it out for case one. Okay, so case one, the expression inside of the absolute value symbols is positive. So take a quick look at that. We have an absolute value bars t minus 42 equals 18. So we break out of the absolute value bars and get t minus 42 equals 18. We're going to add 42 to both sides. Oops. Okay. Apply the addition property of equality there. We get t equals 60. Okay. When we check it, we're just going to plug in 60 for t over here in our check it zone. We get 18 equals 18, which is a true statement. That is case one. So all you do is pull the expression out of the absolute value bars, keep whatever is equal on the other side a positive, and we'll go from there. Okay, that's case one. Case two is a little different. If you look here, I have t minus 42 in absolute value bars equals negative 18. Okay, we're going to slap a negative on whatever the absolute value equals. Okay, the expression within the absolute value bars or symbols is negative. All right, which can be a little confusing, but I'm going to walk you through it. So again, we have t minus 14 equals negative 18. Do the exact same thing by adding 42 to both sides. All right, when we do that, we get t equals 24. So let's go over here and check it. 24 minus 42 equals negative 18. Okay, and I mean that actually equals negative 18. Okay, when we pull the negative 18 out of absolute value bars, it's a positive 18. So 18 equals 18, which is a true statement. All right. So you do one and two different cases. All right, let's do this next one. 2 multiplied by an absolute value bars x plus 9 equals 14. You have to isolate the absolute value expression on one side of the equation before you can do anything else. So let's do that. So I did the distributive property by dividing 2 on both sides to get x plus 9 equals 7. I'm just going to draw a line so it's confusing, okay? So let's just solve it. We're going to keep our 7 positives. It's our first case. So I subtract 9 on both sides. I get negative 2. All right, we're going to check it here on the next page. Then we do our case number 2 over here in purple. Okay, x plus 9 in absolute value bars equals negative 7. I pull my x plus 9 out of the absolute value bars, and I solve. X equals negative 16. So let's check it. When I solve my case number 1 and I put negative 2 in, I do the exact same thing. Okay, I'm not going to divide 2 on both sides because here it's more of an expression. So we're just going to solve it. So I get negative 2 plus a positive 9, which is 7. Okay, pull that down. 2 times 7 equals 14. Okay, now I know you may never have seen this before, but when there's nothing in between a number and an absolute value bars, it's just very simple. You pull it out of the absolute value bars as we did, and you're going to multiply those two numbers together. 2 times 7 is 14, so 14 equals 14 is a true statement. Same thing over here. Okay, solve within the absolute value bars. So we have negative 16 plus 9. That's going to be a negative 7. Okay, pull the negative 7 out of the absolute value bars. Everything inside the absolute value bars is going to be positive. 2 times 7 is going to be 14. 14 equals 14, which is another true statement. So your solution set here is negative 16, comma, negative 2. Okay, do you see how I'm writing or in between these? Either or is correct, so that's why we put it in a solution set. All right, if you look at the top of page 59, I want you to do that example number 2 at the very top. So let's do it together. So we have 3 absolute value bars. wants to work for me. Here we go. Y minus 2, close absolute value bars, minus 4 equals 11. Okay? Okay, so if we look at this, we've got 3 multiplied by the absolute value of y minus 2 minus 4 equals 11. Okay? As we did in the other problem that we just did, we have to isolate the absolute value bars, whatever is inside of it. So let's first add 4 to both sides to get rid of it. Okay? We have our absolute value y minus 2, close absolute value bars, equals 15. We've got to get rid of that 3 to isolate the absolute value expression. So let's divide by 3 on both sides. Then we've got the absolute value of y minus 2 equals 5. Then we can solve it through case 1. Then we can solve it through case 2. So right now I want you to pause the video. Again, this example is at the very top of page 59. I want you to try and do it by yourself. If you can't, then you can go into the book. Okay, so pause it and try it out. Okay, we're back. So I'm hoping that you got down to y minus 2 in absolute value bars equals 5. If not, just copy this down. No big deal. Okay. Then this is how we're going to finish it with case 1 and case 2. So over here we've got case 1 on the left. Case 2 is over here. Okay. First time for case 1, all you do is pull the the expression out of the absolute value bars. We did. Y minus 2 equals 5. Keep your number after the equal sign positive. We solved. We have y equals 7. Then come over here to case 2. Pull it out of the absolute value bars. Same thing. Y minus 2 equals a negative 5. Then we solve. We add 2 to both sides. Y equals negative 3. I want you to check it in your notebooks. You'll find that it is correct, but please make sure that you're showing that you're checking it to make sure that both negative 3 and 7 produce true statements in case 1 and in case 2. And you'll notice too down here, right here, whenever you're writing your solution set, I want you to write it from lower to higher numbers too. So I have negative 3, negative 7. I know my brackets are terrible. That was not too bad. Okay. The last 2 things I want you to know in this lesson are that not all absolute value equations have 2 solutions. Okay, the first one is if an absolute value expression equals 0, there is only one solution. So for instance, in this one right here, in absolute value bars, we have x minus 8 plus 20 equals 20. Before we can do case 1 or case 2, we've got to get it down and isolate the absolute value on one side of the equation. So when I do that and I subtract 20 from both sides, I get x minus 8 in absolute value bars. When then you solve it, as you did right there, okay, all you can do is add 8 to one side, to both sides, and that is your one remaining solution. Because x is 0, you can't do a case 2 for because you can't put a negative on a 0. Okay? The second case, or the second issue, is if an absolute value expression corresponds to a negative value, there are no solutions. So right here we have an absolute value bars y minus 2 plus 7 equals 1. Got to isolate the absolute value. So I'm going to subtract 7 from both sides. So then I have y minus 2 in absolute value bars equals a negative 6. Now you're probably asking, but in case 2, we put a negative on our original absolute value equation. And you're right. But in this one, it has to start out equaling a positive number because absolute values can only be positive. And if you put negative 6 in there, you would see that it would not equal a true statement. Okay? So make sure that you copy down all these notes correctly. And then after you do that, I want you to complete the try these numbers 1, 2, and 3 in your book. So again, if you get stuck, you get stuck. But you've got to at least try it out, use your notes, and see if you can do it. Okay? make sure that you also check your results to see if you have a true or false statement. Okay? All right, I'll see you tomorrow in class. Good luck. Bye-bye.